So welcome back to our data structures lecture, which is basically C++. And today would be the easiest lecture ever, since you already now have some experience with programming. So it concerns control structures in C++. And since you already have some experience with C language or some other languages, so this is really easy stuff. Basically, it's just the conditionals, loops, things like that. We'll look at some of the control structures here quickly. I think we can also play around. We'll play around with this. Maybe I'll see how easy it is to set up a development environment for C++ locally on a school computer. I'll see. It might be possible, maybe during second part of the lecture. So let's go through the slide, official slide. This is a book. Basically, so this book assumes you don't know anything about programming, right? And you guys are smart, you know, right? So you stop me if you search something you've never seen, right? But I'm sure it's not going to be, again. So, well, conditional operator maybe. There are a couple gotchas. There's some foot guns. Okay, gotchas or foot guns or danger, right? Some danger, some difference. There's some things you shouldn't use in C++ or be very careful, right? So, one of the ideas is avoid using something you're not sure how it works in C++, right? You saw it in some other language like in Python, and you want to use it in C++, well, be very careful, right? If you're not quite sure, don't use it, right? Because there's plenty of stuff, because C++ is such a big language, it includes everything, pretty much everything possible. Use only things you know exactly for sure, right? So of course we need the control structures, otherwise you don't have a Turing complete language. We need at least one if conditional branching, or some sort of conditional branching, right? Jump somewhere on some condition, right? Usually, of course, we have multiples. We have if statements. We have looping constructions, which usually include some sort of conditional jump. We have some switch case, things like that, right? So we need selection and repetition, right? So false true, right? You need to have two branches, at least two branches, right? Technically, yeah. That's all you really need to have a full language, right? The minimal language could include a single conditional jump, like original Turing language, original Turing tape had this, right? So again, if else, I think you don't really need to know anything about this one, right? It works just like everywhere else. If something, right? The only thing is, of course, what is true and what is false, right? So these are the operators in C++. Again, no big surprise, all good well-known operators. Again, if you're using some more modern language, there might be some additional ones, like in JavaScript you have triple equality, things like that, right? In C++ you only have these ones, right? So, expressions, it always checks if it's true or false. On true or false, there's such a concept as true-C values in C++, right? This is what you need. So, C++ reference, reference, right? Logical operators, right? So, pretty much anything that is not zero is going to be true, right? The one that is going to tell me here, right? What's truth, right? Basically, not zero, right? Pretty much that's basically the general rule of thumb. Don't quote me on it, because of course there might be some exceptions, right? Let's see if it mentions, because why? Well, so 2 is true, right? True C, it's true C. It's 655 is true. Well, this is also probably going to be true, right? RBS is true, so on and so on. So pretty much any non-zero value, right? So this is a question of Stack Overflow 10 years ago, right? So let's see, right? There's no booleans basically, that's the thing, right? So, you convert to boolean, right? So, as a result of converting, this is the answer from somebody, Keith Thompson. It looks very authoritative, 260K feedback. Again, don't trust him completely, but it still looks like true. So, 0.0 is false, 0 is false, null pointers, we will get to null pointers, is false. So pretty much anything that is non-zero is going to be true. So that's your rule of thumb in C++. Why is this important? Because sometimes it's very convenient sometimes in C++, it's convenient to use some values directly as booleans, right? Modern languages try to avoid this, right? In C++, you can use if this, right? If some string or some number, you do something, right? So you don't need the extra check basically if it's non-zero. So you're basically checking if it's non-zero, right? So we'll see some tricks with this, right? So operators, right? So this is true, right? So 6 not equals 6. That is false, right? Again, for purpose of comparison, well, larger, smaller, or less floats and integers, you can compare them easily. Be careful with the comparison of floats directly for equality. That's a little bit careful, right? Because of float, of the way how floats are implemented. But yeah, so this is all well-known stuff. Comparing characters again. Well, characters are 255 values, right? Again, so logical to the 4 less than 6, right? That's numbers. Or is R more than T, right? So R is, what's the value of this? What do you think? It should be false, right? The second one, right? And also this, by the way, this is combined, of course, and here is not used as the operator, right? Because C++ does not use and as Python, for example, right? So if you'll be using double ampersands, so R over T, right? So but is this second part here enable thing? So this part here, come on. So R is character R or more than T. What do you think?
False.
Yeah, false. Why?
Because T has a bigger ASCII.
Yeah, ASCII, exactly. So T has bigger ASCII value. If you go to a cheat sheet, ASCII values, right? And of course, you don't even need to know this by hand, right? So R is what? Capital R is 82, and T is 84, right? So again, of course, but R, see, so T 84 would be less than R small r, right? So that's you have to keep in mind, right? Again, if you're doing these type of things, right, you have to consider the ASCII values, right? So, okay, so that's something to consider. Now, so if something, right, I think this is a standard classical C-type syntax, right? And don't have to worry about it. I mean, this is like learning about some English expression or Latvian expression which you've been using all life, and you say, okay, yeah, this formally, yeah, like this. But you'll see, of course, also oftentimes. So notice here, C++ does not require curly braces, right? So I would advise to use curly braces for compound statements as much as possible, because oftentimes you need more than one statement, right? For simple ones, yeah, you don't need the curly braces here, right? So, yeah, if statement, this we don't need to know. So if else, again, so branching, do one or other, again, only one of these will be executed, right? Is it possible nothing will be done? Well, if something breaks here, but technically you should program should not halt. One of these will work, right? One of them, not both, obviously, right? So same thing, right? So Boolean did not provide Boolean values, right? So completely. Question is bool in C++. Let's see which version bool C++ and C++ reference, right? So bool, right? Bool type, right? It's integer type. Only so actually, yeah. So question: when was it added technically? A good question actually. Because I don't see it here. Do I see it here? Right? I don't see it here. So bool is actually technically integer, right? But 0 or 1, right? Right. So size is 1. Underneath you probably have a single character, right? So original C didn't have booleans, but of course we use integers, right? Same early C++ is the same. So technically there is a bool. I think since C++, right? So yeah, okay. So since year 11, so since 10 years ago, you do have bool, right? Again, there's some standard. You don't have to read this, right? Because all you have to care that boolean is 0 or 1, right? Takes 1 byte, right? Not just a single bit. there's also bit fields, right? So what else? Yeah, true or false, reserved words, right? And of course, again, this is a classical C type syntax, so there's no, you don't use Python, this is the exception. Most languages use these. So this is what? Negation, right? This is logical and this is logical or, right? And this is all these three operators, you can do everything, right? So you can make more complex operators, of course, right? So logical operators. Only thing, of course, is this negation, something. What's not val this, right? You have string, not val this, right? You reverse the truthiness of this sometimes, yeah. C++ has all these kind of tricks, like when you do negation sometimes, right? Might be handy. We'll play around with this, right? So true, non-zero, right? So non-zero, right? And you reverse it, it's going to be false, obviously, right? So reversal, right? True. You check whether A is over more than B, is character, right? It's reversed, true and false. Right here, false. 6 less than 2 this is true, and you negate it to false. Okay. Again, I'm sure all this is going to be second nature to you already by now. But if something is not clear, let me know. Again, yeah. So you can combine expressions. You can have big chains. So far, it's all pretty much similar to most other languages. When we get to something which is, or, again, so what's or means if you have one or both sides are true, right? True tables, all you really need in programming. And somebody asked me, how much math do you need in programming? George put Boolean table, Boolean math, right? Boolean algebra, right? Do you need these three structures? These are great, right? But basically, this is all you need. This is all the math you need in programming, technically, right? Only this little table, right? The rest is nice to have, but you need statistics and all that good stuff is good. Linear algebra, good stuff, but this is all you really need. If you don't have this, right, then you have a problem, right? But yeah, so. But and Nora, this is second nature. Because oftentimes, of course, in programming, you have to follow long chains of these and, or, right? And of course, the skill with you when reading somebody else's code, right? Or actually making your own, is how to avoid these unnecessary long chains, right? Oftentimes you can optimize the code so you don't need this big nested if else chain. Maybe you can make it simpler to read, right? Because it turns out we humans are pretty hard. We have a hard time reading these long nested chains, actually, right? But I don't want to see programming as programming horror nested if else, right? Let's see video. Why do I have again? I'm back again to check. Let's do English. Sorry. Yeah, video Atel. Yeah, don't do this, please, right? Yeah, this is, this, right? This smells horrible, right? Yeah, right? Programming horror, right? So there's even a whole subreddit for this, right? If you want to see, and this, at some point, if it's late night and you don't know how to figure this out, and you start doing this, right? Try to, hopefully fix this, right? If you expect somebody will. And look at this. This is actually horrible. I mean, obviously, this smells like switch case at least, right? Again, because we have to. If you want to follow this chain of thought here, what's happening actually here, right? It certainly looks like it could have been written. You want to. Your goal, your platonic goal in programming should be make everything as flat as possible, right? Maybe one or two nested ifs, maybe, right? But there are constructions to make your code flat, right? This is bad code smell, right? So, again, maybe you're doing something and you think like, okay, this is the only thing we can do. I can assure you there are ways of making this flatter. And here it certainly looks like you could just do a switch case, right? And make it flat here, right? Yeah, the two traveling herds. And you can probably do something else too here. I don't know what they're trying to do. They're trying to do some Mac checking. This looks like PHP to me. I don't know. Is it PHP or? translate PHP by the dollar signs, right? But no, I don't know C++, but of course, very similar syntax, right? Okay. So left to right, precedence. Okay. Do we need to learn this by hand? No, but I think you will pick up on this, right? Of course, some languages have slightly different, so these are first, right? These are evaluated first. Unary operators, negation, right? Also plus, well, doesn't really do anything. I don't know actually, where do you use unary plus? I don't know where is it actually used, right? Right? Unary, right? Maybe plus plus, but not plus, right? And multiplication, and this doesn't mention the plus plus operators, assignments, right? This is not full table, right? So let's look at the full table. Order of precedence. Plus simple reference. Let's see if we can find a good operator precedence. Is there a good table? Yeah, there we have a table. Actually, scope resolution, right? Namespace resolution is first. So postfix first, right? Function calls, right? Member access, we'll get to classes later on. Prefix, so this is actually would be what you want to consult if you're not sure, right? Again, and not something to keep in, don't need to remember this. And all the things are just, I think, kind of makes sense, right? So obviously multiplication before addition, right? So where are parentheses here? Parentheses, well, I think here, right, you will see them, they will take precedence somewhere here, right? Again, I don't know if it's exactly here, but bitwise shifts are come after, bit operations, ternary conditions after, comma is the last one, it turns out, right, in this big table. Right? So, because what operator precedence? I will put this here, do I have it in a course materials? Yeah, let's do it. Operator precedence. Address. Precedence is C++. Add, so you have it. You're not going to be tested on this, but obviously, sort of keep it in mind. Now, if something weird happens in your code, check the precedence. Now, yeah. So now we get to these some of the examples. True, right? It's true as a boolean, right? So not found is going to be false, right? But what's going to be not age, right? That's going to be age is truthy, so you do a reversal, it's going to be false, right? 0 basically also possibly, right? So false, right? So not age. Over 40 is true. So not found an age over 18, right? It's false. Why? Because if found is true, so again, we're combining logical operators, right? Found is false, not found is false, right? So one false statement ruins the whole AND chain. Here I only have one single one. So where you have to be careful right here. So precedent, of course. This is checked here first, right? Parenthesis first, right? Parenthesis here, okay. So this is careful. So this is okay. This is again. If you're not sure, you can use parenthesis. Don't worry about it. I mean, it's not. I'm not going to mark you against it, right? So this is fine. This one here, you have to be a little bit careful, but it should be right. This part here, left side and right side will be evaluated separately, right? Yeah. And only then N will be applied, right? So this is going to be A is less than Chi, and what's Chi? It was something like B. Okay, B. Okay, yeah, B. So A is less than B, and B is less than Z. So these are all okay, but and fine. You have to be careful, right? Strings. You can do strings also. So how do you compare strings? By character, I call it like a penalty method in the soccer or football, right? You compare the first one, right? What are the strings? Hello on hi, right? You check hi, H, right? Just like in Python, right? And then you check the second character, right? E is less than I, right? So string 1 is less than string 2. Okay, and again, I must again, stop me if I'm saying something completely incomprehensible, right? So far, everything is all basic, right? Okay, we're almost finished now. We're actually halfway through these slides. So string is string 1 equal to hello? Obviously not, because first character is not age. Again, simple. So string 3 less than equals than string 4. What is string 1? Okay, so I can see where actually it's missing some slide. I guess I don't know what string 4 is actually, right? String 4 I guess is A, and this is Bill. Of course A is less than B, so of course it's true, right? And also H is over B because H is more than B. Okay, now this is all nothing too hard. Again, compound statement, we use curly braces. That's our friend, right? Because then you could do everything. If something, or we're going to be using a lot of curly braces in C++, right? Just like in JavaScript, just like in PHP or Scala or Java, right? But unlike Python, right? Because indentation is not important, but good formatting would be nice. Now, right? Again, this is all stuff we've done before. So, nested loops, I mentioned. This is preferable over this. Well, else if this is fine, right? Else if, so this is a big chain, right? If months is 1 is January, months 2. This is how you got to write Python code, right? Python also got match case now, right? It's sort of like, I would say smells bad. Maybe there might be better way of doing it. Maybe you have an indexing or something. Maybe you have some sort of index structure, possibly maybe a dictionary or hash map in case of C++, right? But it's fine to use an if statements here too. But you'll see also there's switch case, right? If. So, what's the difference between this one and this one? Who can tell me? This code, or maybe I don't know if you can make 2 slides. So this part here, it should, let's see, else if, right? And this part here. At first glance, it looks to be roughly the same, right? But main thing is this guarantees that only one output will be produced, right? With these type of checks, right? That's possible. If your logic is off, you might do multiple things, right? Because these are completely separate checks, right? They're just if, right? So it's possible you do like 5 things if you mess up your code, right? So generally this is sort of safer, right? And of course it's also possible in this case, if month is 9 September, right? That's possible, nothing happens, right? So here also, so in this case the code looks like to me it works exactly the same, but right, this would be slightly more preferable. Of course there's also switch case. Now we get to short circuit evaluation. Who remembers this idea? If I taught you Python, I've also thought about this, but so it's all very common in multiple languages. Idea is, if you need to see the first one here, right? Age over 21 or equal, and x equals 5, right? And now your age is 22, right? And x is 650, right? What's going to happen? Many languages, I think C++ also, right? What happens? The engine, right? You check this first, right? And if it's true, that's it. You don't have to do any more work, right? It's very efficient, optimization, really, right? But where does this come into play, right? You say, okay, well, it comes into play if you attempt to do something, if this is part of doing something, right? If you are going to check something and it's going, and then also one of this may be a function call, the function is not going to get called, right? Because
would that be a bad practice of programming?
No, that's the thing. C++, there are some long-standing how should I say, idioms like approaches where this is used, right? For example, you could check whether x is 0, and then you call a function divide 5 by x something, right? Basically, right? It's kind of like a utilized. It's like a bag of tricks. Another thing is, in Python, the short circuit is very rarely used, right? In C++, it appears a lot in the code, actually, right? I would say, if you're not fully sure yet in your homework, right, how it works, it can lead to hard to catch bugs, basically, right? That's the thing, right? But when you write it, right, when you're aware of it, right, it is, it can lead to, very compact code. That's the thing, right? I would say be very, avoid as much as possible unless you see very canonical examples, basically, right? There are some things for some old standing, come from C language from 1970s, right? For reading files and things like that, where you basically, the problem stems from trying to do many things on one line, basically, right? That's where the bugs come in, right? It leads to nice efficient code, but if there's a bug, right, you basically need to put, if something doesn't look quite right, basically split in multiple lines, basically. It's multiple operations, multiple statements, basically, right? Here, right, so here there's no problem, right? You don't really get worried about it, because these are comparisons, right? They don't affect the state, right? They don't call any functions. You're not doing anything, right? I'll show you where the problems appear, right? So, so of course this is false, right? Why, right? This is like weird, right? So so you have floating, checking floats is really weird, right? For equality, float equality is weird, right? Because it's not quite, look at 8, 9, right? We all know math, you say it's stupid, right? But yeah, floats are sometimes really used. And again, it's not C++ only, right? You have tolerance value, right? You could, of course, you could try to, you could average, you could have some like, average up, things like that as well. Tolerance, right? Again, kind of silly, right? That's the way it is. Now, associative. Okay, so this is where I want to show. This is the example I show. And I personally say don't do this ever in C++, right? Maybe it's, I don't touch. Also, I've seen quite a bit of C++ code. I rarely see this approach, right? So what's the problem is this line here. This is where a very nasty bug. This would be completely good Python code, right? If something, not counting parentheses, right? If 0, you enter a number, and it looks like, 0 less or equal, something. This looks good, right? If you're doing Python, right? Nice, efficient code, but it's not. It's just bad. It's just a really bad code in C++. Why? It's basically a bug. You see this?
Completely different.
Yeah. So this part here, right, looks okay, right? It works as expected, right? But here the bug is. The bug is here, right? You enter a bigger number, right? On the precedence, this is what's happening, right? 0 less or equal 20 is true. That's 1, right? And 1 less than 10 is 1, true, and you get. Basically, this is using C++. The way it's not really when C++ was made, it is not this sort of like comparison was not really. It was not meant for this type of operation, right? So don't do this, right? So this is the one thing you should avoid, right? So this is one of the precautions, right? So do you guys understand why it's happening? Yeah. Yeah. So because it's evaluates one, it's not that it does not have the special. It does not have the special construction. It's just doing one. It's only doing these, right? One left side, and then this is something true or false, 0 or 1, right? And checks it again, right? So for large numbers, there's going to be hard to catch a bug. If you are basically using too much Python or something, right? But yeah, so don't do this. This line here, this row is just bad. That's why it shows you. The book shows you. Okay. So yeah, if you're not sure, right? The book, yeah, I agree. If you use the partial, how are you going to learn anything, right? Without breaking things, right? Yeah. No, you should try it, of course, experiment, right? Try to see where the bug is, right? If you want to understand it, the technique, use it. And of course, also, there's a curse. If you know much different languages, right? You switch it, right? Especially C-type languages, right? C, C++, Java, PHP, JavaScript, and so on, right? C#, and there are subtle differences sometimes, right? So it's again, so using the most basic constructions will be safest again. Because only then, of course, when you feel comfortable, right, if you're only doing C++ your whole life, of course, then you can do all the tricks, right, try to avoid them, right. So, input failure, we took this last lecture, so don't have to worry about this fail statement, right, right. So this is second bug. Luckily, this is one of the most insidious bugs, but luckily most checkers will find it, right? So C++ lets you do this. So what's the problem?
You're assigning.
Yes, one of the most famous bugs. Because why? It's the tendency of C and C++ to sometimes it's useful, right? So basically, you sort of like check. So is this never almost right? Right, it's a silent killer, right? It's not it's most likely a logical error, right? Because of course, this is like if true, right? Right? Right. So assignment here, right? Yeah, so usually when you're compiling, there's various flags, it'll pick up on this error, right? Right? So some languages don't let you do this at all, but well, the C++ lets you do it. So any expression, right, true or false, right, well, so this one again, your IDE, right, so conditional operator, again, using one is fine, so you check this for true, right, if it's true, this is A, right, so max, whichever is bigger, right, A equal to bigger or equal to B, A is going to be assigned to max, otherwise B, right? You see this. How many people use ternary operator? You guys use it?
Sometimes.
Sometimes, yeah. Also, most languages use this type of C++ operator. Python is kind of reversed, right? They use a little bit different syntax, right? Right. Again, so it's nice sometimes, but again, it's completely not needed if you're afraid of it. Use if else, right? If A more than A and B, then it's A, max is A, otherwise it's B, right? Now, of course, again, these are just basic suggestions. Properly in the program to fix errors quickly, right? Of course, right? Again, C++, you can put everything in one big line, right? But no, also you can do obfuscated, well, it's obfuscated C contest, right? This is running for like multiple years. Let me see something from old ones, right? Yeah, I like this. This is C language, but actually I think it'll compile in C++. This is the old one from 1980s, I think, right? So this calculates value of pi, right? Right. So you define f. I think you define one underscore as f to 0, 0, and f as or f minus 0, 0, there's some operations, some speed shifts, the minus minus, right? And long f0, o is o. Yeah, this is scary stuff, right? Right? But yeah. And there's still a short circuit evaluation in there. So this is something. This is what people used to do when they had nothing to do with C++, right? When they get bored, right? There's many more examples of this, right? Again, of course, it's mostly C, but most of these tricks work also in C++, actually, right? Yeah. This code has been running for multiple years. Some winners, been mostly very famous people, actually, very good programmers usually, right? Yeah. Right. So this is something we'll see also maybe more future lectures. Now, what else? So pseudocode, of course, yeah, you can do this, right? Again, switch statement, right? So again, this is more limited than match case used in some other language, such as Scala, or also I think in Python the match case is a little bit more powerful. But the idea is this, right? So what's important to remember from this one is the break, right? What happens if you don't have a break? Anyone?
Question.
Is this going to be an error? No. Again, we'll taste this after the break. We have like 4 more minutes. We'll take a break in a moment. But what happens? What do you think? Let's say if it's 5, if it's value 2, nothing happens. But if I remove this break here, well, it's legal in C++. It's something called fall true. If it's 1, it will do both things. It will do if it's case value 1. Let's say it's 5, right? It's 5. Value 1 is 5, right? It will do the statement 1, and it will also do statement 2 without break. So it's one of those things. Again, you have a lot of freedom to optimize your code, right? Again, so generally you don't want to do it. Generally you want to make your code all breaks, right? But sometimes it might be useful to do this. Again, it's one of those things, right? So you keep checking. It's basically like one big chain of if-else statements, right? If value is 1, right? If expression is equal to value 1, then 2 or 3, you keep checking. And if it's nothing else, right, then you do the default, right? But that's with breaks. If you remove some of the breaks, it's really hard to follow code. Now we'll check all this switch case. We'll check this all in a, yeah, so something like this, right? A, B, C, and so on. We'll try it, right? Yeah. Generally, its break is good, unless you really know. And last thing for official materials, I think, is assert, right? So this is sometimes you want to place, especially for debugging purposes, you want to place some assertions, meaning logical statements of what should be true, right? It is actually assert, I believe it's macro, right? Yeah. It's preprocessor directive, meaning it's gonna, you define and debug, right? And then this means if you compiling for production for end users, you remove this, this definition, and then you won't have this assertion. But when you are debugging, right, this might help, right? So you want to check basically whether something, whether something is true, whether some condition is true or false. We'll play around with this as well in the practical section. So a review of all this theory. So control structures, again, nothing new here. Logical expressions, again, nothing new. Everything, just very careful with using some non-standard, like I said. So the key takeaways today: don't use the Pythonic 3-way comparison. So don't use this one here, right? Where is it? Yeah, so don't use this one, right? This if statement is bad, right? And what else? Because it leads to hard to catch back, and of course, be very careful of this. Again, usually the compiler will pick up, or even AI will yell at you for doing stupid things like this, right? On the switch case, of course, you include break. Okay, we'll play around with this after our own break. So let's take a break till 12:10. 15-minute break.